G'day guys, and welcome to today's video on the general equation of a straight line. Yes, part of the further Maths 3 and 4 course over here in Australia. Now, don't worry if you're not in Australia, because the general equation of a straight line is freaking useful for all sorts of maths from year 9 and onwards. If you are new to my channel, it's so good to see you here. Welcome. Can you subscribe for me? Yes, go over to YouTube, MaffsGuru, and subscribe. Or if you are watching from my website, MaffsGuru.com, then hello, welcome. Yes, you are the lucky ones because you can sort and search these videos by textbooks and have downloadable notes as well. If you are not on MaffsGuru.com, head over there. So what are we doing? We are looking at the general equation of a straight line. And yes, by the end of this, we need you to be able to realize that straight lines have an equation. It's effectively a relationship. Yep, none of that hand-holding stuff here, please. Thank you very much. But yes, it is a relationship that basically tells us if we know an x value, we can find a y value. We know basically that an axis is split up into loads of values, x values and y values. And generally speaking, if we have a coordinate, we go across the x value and up the y value, and we would read that off. Well, we can actually create equations that allow us very much to draw these things, or at least work out how to draw them with some actually quite funky math, some of which you've already done in a previous video. Now, yes, as I say, in that previous video, we have looked at gradient as being two things, rise over run and a y2 minus y1 over x2 minus x1. So if we have 2 points, if you remember, and we have the value 1, 3, let's say, and 7, 10, brilliant, fabulous, fabulous, thank you very much, then we can either join them together to make our straight line and then turn it into a right angled triangle and look at the difference in how high this triangle is. And so how would we do that? Well, we know that the height finishes at 10 and it starts at 3, so that has a height of 7. How wide is this? Well, if we were on some sort of axis, we'd read off the scale. But again, we know that it starts at 1 and finishes at 7, so it becomes 6. And in which case there, my gradient will be equal to the rise, which is 7, divided by 6. Not a particularly nice number. It's irrelevant at this moment in time. But we also have to make sure that we understand which way the gradient is going, positive or negative in this situation. And I'm sure there's other ways of doing this. I personally like this y2 minus y1 over x2 minus x1 business. And again, to explain, we've got 7, 10, and we've got 1, 3. So if I use my gradient is equal to the y2 minus y1 over x2 minus x1, then we know that our y2 value is 10 minus 3 divided by 7 minus 1, which again gives me 7 over 6. And here I don't have to worry about the positive and negatives because, believe it or not, the equation does all that hard work for me, and it will show me whether my gradient is positive or negative, or in fact 0, or maybe infinite, all part of a different video. Now, the thing that you're going to need to know for this particular section of the course is not only the gradient, something called an intercept. Now, if I was to draw, again, a set of axes, here is my beautiful set of axes and a bit of a straight line there. Well, at this moment in time, is that actually all the straight line that exists? Probably not. And I actually like to say that it continues to infinity and beyond. This straight line actually continues all the way up to infinity that way. And in fact, it crosses and goes all the way back to infinity that way. And so while it is important and useful to know what the gradient is of this line, we also need to know a particular point on the line. And I'll explain what I mean there in a moment. So if we have a point on the line and the gradient, we can actually draw that whole thing. Now, as I'm going to say a little bit later on, one of the most useful points to us, or one of the points that they generally give us, is that thing there called the y-axis intercept. All right? Now, why is it called the y-axis intercept? Because it hits the y-axis. Yeah. So if I know the gradient and the y-axis, life is really, really good. So let's sort of build it up in stage by stage, right? If we have an example here where we have a coordinate 1, 3. Now at the moment I've got some grid paper here. Let's draw a set of axes, and I'm just going to use the edge here. Not particularly straight, not particularly nice, but obviously you guys will be able to do it much better because you'll have a ruler. So there's my x values and there's my y values, and we'll go 1, 2, 3, 4, 5. And that's going to be 0, and we'll go up 1, 2, 3, 4, 5, and continue. So when we draw a straight line, we need to know a point on the line. And in this situation, we've got 1 point as 1, 3. So there we go. I'm going to do a dot where that point is. Tick. Thank you very much. Good to know. What does the gradient mean? Well, if we remember, a gradient stands for nothing more than a value of rise over run. Now in this situation, it makes much more sense to think of it as rise over run rather than y2 minus y1 over x2 minus x1. Why? Because what this now tells me is for every one rise, I'm going to go 2 runs and then draw a point. So starting here, I'm going to go up 1 and I'm going to go across 2, and there, ladies and gentlemen, is my new point. And again, a lot of people go, well, I can draw my straight line now, can't I? And I'm like, well, you can, but generally speaking, we like to have a minimum of 3 points, maybe 4 if we can. And this is just as simple as going, well, from this point now, go up 1 and go 2 across and do a dot. Go up 1 and go 2 across and do a dot. And ladies and gentlemen, what can we see there? There is the start of a beautiful straight line. Now again, that straight line goes on to infinity and beyond, and it will also cut through there as well. Where does it cut through? Well, that's something we can find out in just a moment. Word of warning, although I am drawing dotted lines here, probably not a good idea for you to draw dotted lines. Just draw a straight line, but only do it where it makes sense to do so. Now I know for a recent SAC my class did, we had something called GDP on the x-axis, that's gross domestic product, and in that situation it made no sense for the line to go further past the y-axis. So we were sort of tricking people, and if they did their graph like that, it was incorrect. What they should have done was realize that it should just start at the x-axis. And again, we generally don't draw it outside of where the axes are. I like to think of this as sort of a frame, like a picture frame, and so in which case that piece wouldn't exist. Yes, I could possibly take it to the limit of there, but I wouldn't necessarily take it any further. So as I say, normally we have 1 point and the gradient, and in many cases they'll give us what we call this y-axis intercept. So again, let's draw a set of axes. Let's draw it actually inside this time just to mix stuff up. Wait for PowerPoint to catch up with me. There we go. So this is my y value and this is my x value. All right, so 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So let's see what the question says. We might be told the y-axis intercept is 3. Now again, that's just another way of giving you a coordinate. 0, 3. That means we're not going anywhere along the x-axis, but we're going 3 units up my y-axis. So there we go, ladies and gentlemen. There is my first dot. Well, let's do a little kiss now. Kiss. Anyway, now we have a gradient of 2/3. So 2 on 3, that is equal to my rise over my run. So every 2 I go up, I'm going to go 3 that way. We'll worry about minus signs in just a moment. So 1, 2 up, 1, 2, 3 that way. So there's a cross. 1, 2 up, 1, 2, 3 that way. I got 3 coordinate positions, and ladies and gentlemen, I can now join those together to give myself a line. And again, that line would continue outside my axes, or at least up to the limit of my axes. So let's do it sort of there. Would it go back further? Very much so. Would I bring it back this way is what I mean? Very much dependent on the context of the question that we have. So having a point and a gradient, freaking awesome. Now obviously lots of people get tricked, sadly, with these type of questions. And so if I have a set of axes here that let's go through there, and basically if I have this as -1, -2, there is 0, 1, 2, 3, 4. And I have a line that does this, for example, and that's really slow. I don't know why PowerPoint takes so long to actually draw a line, but assuming that that actually crosses through the point 3 there, what you can see now is it crosses 2 axes, right? There are in fact 2 intercepts. There's this one here at the point 3, or we'll pretend it's there, and this one here at the point -2. But the equation of a straight line is quite clear that it must be the y-axis intercept. This one here is the x-axis intercept. Not useful to me at this moment in time for my equation of my straight line. So if there ever is this point here, just ignore it because that's not the one you want. You're looking at that as our start point. And again, I'll explain what I mean there in just a moment. Now again, as I've said in previous videos, don't get tricked by whole numbers. They are in fact fractions too. So if I say here I've got a gradient equals 3, then basically we can turn any whole number into a fraction by dividing it by the number 1. And in this situation, we've now turned 3 into 3 rise over 1 run. And so if this was my decimal, say that was some sort of starting coordinate, then I'm going to go 3 up and 1 across. There's a dot. I'm going to go 3 up and 1 across, and there's a dot. Now this is no way in a straight line, but again, the general idea is whole numbers are useful. There is one other gradient we haven't dealt with so far. What if I had a gradient equal to minus a half? Well, this is the funky bit. Let's say that's my start coordinate. We have rise over run. Now in this situation here, I always think of the minus sign as belonging to the top number. And rather than having a rise, that minus sign actually tells me to have a drop. I know that seems weird, but rather than going up 1, we go down 1. So in this situation, we go down 1, but we always move to the right, or to the right the way you're looking at it, yeah? So that's 2 over there. 1 down, 2 over here. 1 down, 2 over here. And ladies and gentlemen, again, this is no way going to be straight, but the general idea is, what do we notice about my gradient now? It is, in fact, negative, yes. So that minus sign, just give it to one of the numbers, and generally you give it to the top number that says rather than going up, go down and then to the right, down and then to the right. And ladies and gentlemen, the whole point of this lesson is the equation of a straight line. And there we go. Gross. Yes, y equals mx plus c. There is another equation coming up a bit later on that I think is much, much nicer. But y equals mx plus c. So what does this mean? Well, as I say here, y stands for my y-axis values. An equation is nothing more than a relationship. Again, still not with the kissing. Enough. Eugh. If we look at a set of normal axes, what do we notice? We notice that the x value goes along the bottom and the y value goes up the side. And whatever line we draw is nothing more than some sort of way of relating, if I give you an x value, how do I find a y value? And it's related to this equation here. So it says to find the y-axis values, that's the equals, take the gradient. Now for some strange reason, m. I know why Barry decided to use m for the gradient. It makes no sense to me. I mean, we could use g, but unfortunately the physicists have chosen g for gravity. Yes, I know. Gravity has a value, a whole new discussion. So you need to remember that the value of the gradient in that equation is the letter m. X, the x-axis value. So again, these are the values we are given on the x-axis that we then translate by using the gradient and the intercept. And the y-axis intercept is given by the letter c. Again, no idea why. I have no idea what it's got to do with my fish. But using this gradient and understanding how it works is freaking awesome. So here we go. Find the gradient and y-axis intercept of the graph y equals 3x minus 4. Let's build up slowly. So we have y is equal to 3x minus 4. Let's compare this to the equation of y equals mx plus c. Now, word of warning, if this equation does not look that way, then my advice to you is transpose it, i.e. move it all around, do what you need to do to make it so the y is on its own, some number times by x minus or plus some other number. And you'll notice here this says minus 4 and this says plus c. Doesn't matter. So let's just compare what's in place. So what do we notice is in the place of the m? So we see that the m in this situation is equal to 3, and we can see the c in this situation is equal to minus 4. All right, so the plus and the minus, yeah, we'll get into that in just a moment. But ideally, we have plus c is equal to minus 4, and because we don't need the plus there, we say that c is equal to minus 4. And so I now know that my gradient is equal to 3, which we know is 3 over 1, so that gives me my rise over run. And we know that my y-axis intercept, if I was going to start this graph anywhere, or if I know one point on the graph, then I know that basically it's here at -4 on the y-axis. Not the x-axis, the y-axis. Do I have everything now I need to be able to sketch this graph? Well, absolutely. I know here that I'm going to go 3 up and 1 across, 3 up and 1 across, and lo and behold, there is my straight line. That's why the y-axis intercept is so useful. Sketch the graph of y equals 3x minus 1. All right, so let's compare. We've got y is equal to 3x minus 1, and we're going to compare that to y equals mx plus c. Do I know my gradient? Yes, I do. My gradient is equal to 3, which is 3 on 1. Do I know my y-axis intercept? I do. My y-axis intercept becomes -1. All right, so what do we do now? Let's draw a set of axes. And across there. Marvelous. And so we've got y and we've got x. Now obviously in this situation I need to have the y value going to the negative numbers because my intercept is -1. So let's have that as 0, 1, 2, 3, 4, 5. And so that -1, -2, -3, -4, -5. Now again, do I need to go that far down? Probably not. In an exam they'll tell you, or they may be lucky enough to give you a scale already drawn. The big thing to do is to make sure that when you go up and across that you use a very similar scale, as in make sure the gaps between them are the same. I'll talk about that a little bit in another video. So do I have all the information I need from this equation? Absolutely. I know that c is -1. So there is my y-axis intercept, my start value, or at least one value on that line, and the gradient is equal to rise divided by run. So for every 3 up, I'm going to go 1 to the right. So 1, 2, 3 up, 1 to the right, 1, 2, 3 up, 1 to the right, and bear in mind my scale could be a lot better. He says trying to draw this together. There is my equation of 3x minus 1. Now how could I have made this better? I could have actually given a much wider scale to my x-axis. So let's actually just do that now. Let's see if I can get rid of this here. Let's go to these values of 0, 1, 2, 3, 4, and 5. And what I'm now going to do is say, well, here is 1, 2, 3, 4, and 5. Now, notice that I've got one little tick mark going up on my y-axis, but I've got 2 going across. Doesn't matter, so long as I've got 2 squares going across, it is fine. So does this make my graph look a little bit better? Let's see. So I'm going to go 3 up, 1, 2, 3 up, and 1 across. 1, 2, 3 up, and 1 across. Well, does it make it look better? It certainly seems to stretch it out a little bit more. It's not quite so scrunched. And lo and behold, there we go. There is my equation of y equals 3x minus 1. There are lots of ways of writing these equations, or at least 2 that I think you guys are going to see. And one of them is this form here. Now, it's pretty funky because that's called the intercept form. When I have y equals mx plus c, the reason this is called the gradient intercept form is because it's written in a way that gives us the gradient and the intercept. Sadly, this equation you've got above you doesn't actually give us our gradient and our intercept. Lots of people go, oh no, but it does. You said, look at the value in front of the x. No, I didn't. No, I didn't. Rewind this video. I don't think I ever said that. And if I did, All right. Lots of people get tricked and they go, well, the gradient must be 2. Actually, it really isn't because of this value here. Now, we'll come back to that in a little bit later on. But how on earth do I use this to draw a straight line? I actually really like this method. It's clever. It's freaking awesome, in fact. So having drawn my axes, there's y and there is x. We know that all the points along the y-axis have an x value equal to 0. And for those of you doing math methods, that's why it's called the line x equals 0. And we know all the points along the x-axis have a y value of 0. Now, why do we like these 0 values? Because when you multiply something by 0, what happens to it? Poof! It disappears. It goes. So using this equation here, if I have 2x plus 4y is equal to 12, and let's make x equals 0. So when x equals 0, we're looking for the y-axis intercept. Well, when x equals 0, that becomes 2 times 0. That disappears. And I get simply 4y equals 12. And so y in that situation becomes equal to 3. Oh my goodness gracious me. 1, 2, 3. There is my coordinate. There is definitely one coordinate on that line just by effectively getting rid of that x value. Guess what we do next? We do the same thing, but rather than let x equals 0, let's make y equals 0. Why? Because when y equals 0, we're finding a coordinate on the x-axis intercept, or the x-axis intercept. So when y equals 0, that disappears and becomes 0. So we get 2x is equal to 12. So x is equal to 6. And then we go 1, 2, 3, 4, 5, 6. There is 6. And there is a kiss. And ladies and gentlemen, we have 2 points that we can join together. Now, undoubtedly, you're going to turn around and say, but hold on a moment, you said we need 3 and maybe 4. Yes, ideally, that's lovely. But in this situation, when we have the graph in intercept form, It actually makes life just easier to have those two. We could rearrange that equation and do something else and end up with y equals mx plus c format. But if I'm honest with you, sometimes it makes life much easier just having it in that format. Here's another example. So we have 3y plus 6x is equal to 9. All right, so what are we going to do? Well, first things first, so we're going to have x is equal to 0. When x is equal to 0, that disappears, and I get 3y is equal to 9. And so y is equal to 3. That's the first bit. And now we can make y equals 0, and then 3y plus 6x is equal to 9. That disappears, gives me 6x is equal to 9. X is equal to 9 on 6. That's disgusting. X is equal to 3 on 2. All right, so yes, we can have fractions. That's nothing more than 1.5. Yes, higher order maths, it's fine. So let's just draw some axes now. He says, waiting for PowerPoint to catch up. Yay, we finally caught up. I don't know why it does that. I'm sure it actually tries and plays them back. But anyway, y and x. So let me see. Let's go up in 1s, 2s, 3s. So it's 3, 2, 1, and 0, and 0. And let's go 1, 2, 3. Okie dokie. So where are my 2 points? Well, when x was 0, y is 3. There is a kitty there. And when y is 0, x is 1.5. So there is a kitty there. And so drawing those two together, he says, in a horrendously not straight line, there is my straight line drawn. All right, I love it when they're this way round. Now, last part of this video is parallel lines. What is a parallel line? Well, parallel lines are the ones that have exactly the same gradient. They will never meet. Those lines will go on to infinity and beyond and never, ever, ever meet. So it's important that you guys know what a parallel line is and how to identify whether they're parallel or not. Now, if the equations are in the gradient intercept form, life is really, really easy. Because what do we notice here? We know the value of m, or the gradient, is 3 there. What do we know about the value of m there? It's also 3. And if they have the same gradient, they are parallel. Tick, they will never meet. When things are in this format, life not so easy to look at. But what we can do is rearrange them. Now, you can use your calculator to do this. But if I have 3x plus 4y is equal to 2, then I can rearrange this and I get 4y is equal to minus 3x plus 2. How did I do that? I'm taking a plus 3x to the other side and it becomes minus 3x. I'm going to divide everything by the 4, because that 4 is times by the y, so I get minus 3/4 x plus 2 on 4, which we can cancel down to a half. And likewise, if I have 3x plus 4y equals 7, then what do I have? So I'm going to have 4y is equal to minus 3x plus 7, and y becomes equal to minus 3x on 4 plus 7 on 4. Now, what do we notice here? Yes, the gradients here are exactly the same. Now, that's a lot of faffing around and a lot of work, isn't it? Yes? Well, actually, there is another shortcut here. All right? If these two things here are identical, if when you have it in intercept form, those two there are identical, then the lines are parallel. Something for your summary book, or just to remember. And ladies and gentlemen, there we go. The general equation of a straight line is done. Thank you very much for watching. If you haven't already done so, please subscribe over at MaffsGuru on YouTube. Just lets me know that you're watching, all right? I have very, very few subscribers, so every person actually matters. Otherwise, head over to MaffsGuru.com, sign up for free, and you can download notes and watch the videos, all linked by textbook. Otherwise, hopefully you will join me for another video. If not, take care of yourself and stay safe. All right, bye-bye.